Okay, with respect to the mass in the spherical shell, the problem about the mass in the spherical shell, which we talked about in class, we established a couple of things. One is, as long as you're outside the shell, the closer you get, the greater the force. So that you don't have simple harmonic motion, because simple harmonic motion, and the condition never was written down here, but the condition for simple harmonic motion is that F net equals negative kx, where x, and this is very important, where x is measured relative to equilibrium position. So, there's your simple harmonic motion. Now this means, of course, that the further you get from your equilibrium position, the stronger the force pulling you back is. That's your experience. If you pull out on a strong spring, you're going to get to some point where you can't pull it anymore. It comes out easily and then more and more difficult. If you're pulling a pendulum back from its equilibrium position, it gets harder and harder to pull back. Say if you've got a 200-pound pendulum hanging from a string, it's going to get fairly hard to pull back, but at first it's going to be pretty easy to move. Gravitation, on the other hand, falls off as the square of your distance from the center. Okay, so the square of the distance from the center, well, as you get further from the center, which would be your equilibrium point, you're going to have more and more force. I'm sorry, less and less force, because the bigger R gets, the weaker gravity gets. Similarly with two magnets. Okay, the further you get two magnets apart, the less force they exert. The other thing is, and we mentioned this, by the divergence theorem, there's no force inside the shell. Now, only one person remembered anything about that. I didn't remember it quite right, but it shows me that at least one person was actually paying somewhat attention. Now, I understand everybody's paying attention, and you got to sort out everything from the booming, buzzing confusion, and that's why physics is challenging. So it was good that somebody remembered that. That person hadn't had multivariable calculus, and my multivariable calculus students aren't going to get the divergence theorem until tomorrow anyway. Now, of course, they've had Green's theorem, so they should be able to infer it, but we'll let them by with that. Okay, so by the divergence theorem, there's no force inside the shell. But we also said it's a small shell, so we assumed the mass doesn't spend much time inside anyway, so it doesn't make a huge difference in the motion. Also told the person presenting this, who has had differential equations, the only person who's had that course at this point, and of course that's not a prerequisite, that he has seen the techniques for solving the equation you get from this force function. But I don't necessarily expect that he'll have time to work all that out. Okay, there's one more problem that was brought up, and we'll talk about that.